I'm Chad, I'm 9th grade.
I'm Catherine in 7th grade.
I'm Max, I'm in 8th grade. I'm Chris, I'm in 9th grade.
I'm Thomas, I'm in 8th grade.
I'm Alex, I'm in 8th grade.
I'm Sam, I'm in 7th.
I'm Ava, I'm in 7th grade.
I'm Will, I'm in 9th grade.
I'm Ashley, I'm in 8th grade.
I'm Nolan, I'm in 8th grade.
I'm James, I'm in 8th grade.
Hello, we are Team 7254, the Nerds, from Schiller Junior High in Michigan. We started our initial robot design by analyzing the game rules and how to score points. And on top of that, we really wanted to trigger one beacon, score 2 particles in the center vortex, and then park on the center when in teleop mode, we wanted to score 8 particles in the center vortex. And in the end game mode, we estimated we could trigger at least 2 more beacons. We also had a stretch goal to raise the cap ball up to the low zone and get 1 more beacon in on time. This gave us an estimated total of 170 points. At our last competition, we had 4
After we decided what we would do in the game, we had to decide how we wanted to accomplish this. So we gathered around the table and brainstormed some of our ideas. And then after we came up with ideas, we set up a Q&A checks where we compare our ideas against criteria to find what would work best. And so our initial robot design, which we ended up changing, we chose a 4-wheel design with 6-inch wheels in the back with tread on them, giving us speed and traction, and omni wheels in the front. And to gather particles, we chose a sweeper, which we still have up front right here. And then we chose an elevator to raise the particles up to the shooter right here. And then we chose 2-wheel shooting designs to give us variable speed and power. And that's what we initially set up for.
Our robot had a lot of hardware prototype before we came to the for the sweeper, we started off with a metal rod and added rubber strips to show the sweeper. Our elevator started off to show the raised particles. Our shooter started off with 1 and 2-wheel designed by themselves to see which one worked better. We found that 2 wheels worked better for the shooter. We integrated all the prototypes to our chassis and combined together.
Robotics is more than just building a robot. Outside robotics, we want to get back into it. We went to an inner city school in Pontiac, and we made math games for elementary students. So these math games help show how math can be fun and how it's important for us to use in our everyday lives. Also, in Pontiac, we went to Convenience, which is a food bank, and we practiced food for food. So we went to a food bank in Pontiac, it's called Convenience, so we packaged food. Also, through the Desert Angels program, we sent our troops overseas care packages to help the minority.
So outside of robotics, we gathered as a team for fun things. We went down to Tellson Street in Romeo, Michigan, which is a famous street in our area, known for extravagant decorations, and each neighbor tries to outdo the other neighbor. And while we're here in St. Louis, we're taking advantage of the opportunity to come down here. And so we're going to go see the famous art and museum that are here. And we also got some industry exposure in engineering. At our builds at Arctic FX, we got to see some graphic design and how that works. And we also took some field trips to TRW and we got to see crash demo tests. And as well as while we're here, we're going down to the GM car manufacturing plant in Huntsville.
Okay, we also had several learnings, and we modified the robot to continuously improve it. Our first improvement was increasing our shooting angle for a shorter shot to improve the accuracy over a longer shot. We originally had a longer shot for Auton, but realized we could overcome this need. Our next improvement was in our maneuverability. We improved the maneuverability by cutting the turning radius in half. We moved the drive wheels from the rear face of the robot to the center. As a result, the robot is now quicker and easier to drive. Lastly, we increased our beacon pusher surface area by over 100%. We went from having a single beacon pusher to a dual, these two right here. On top of that, we added a beacon pusher bar to the rear face of the robot.
We have a gyro sensor on a robot. It is like a digital compass that gives an electronic heading. Our robot uses it during Auton to correct encoder turns and ensure the proper heading. One problem that we would run into at previous competitions, however, is that we initialize the robot and any delay or vibrations in the match startup would cause the gyro to drift and cause driving to be unpredictable. To fix this, we now display the gyro heading on the phone, and we changed the code so that it would be zeroed as the match starts. We also ran several tests to try and determine the performance of the robot. One of these tests involved commanding the drive wheels to a certain power setting, allowing it to drive for 1 second, and then commanding it to 0 power. We ran this with power settings from 10% to 100% in 10% steps. These graphs show the resulting distance versus time for these runs. The slope of distance versus time gives speed, so the curved part at the beginning and end of the map show acceleration and deceleration, while the linear part in the middle shows the constant top speed for each power setting. These graphs gave us 3 important sets of information. Time and distance needed to accelerate at the given power, the speed for that power cycle, and time and distance needed to come to a stop at that power cycle. This information is critical when deciding the most efficient power setting for our driving cycle or for our auto driving turns.
Let's talk vision processing. We first used Vuforia, which is the use of the pictures underneath the beacons to find a position on the field. This didn't work because it would give us the wrong position, so we got rid of it. Instead, we used the basic color blob detection using OpenCV. However, this was affected by the light conditions in the room and people in the background. So instead of getting rid of this, we made it more advanced. We added additional features, including the buttons on the beacons, the width, and the height of the beacon. This allowed us to get the X position and the Z position. The Z position is the distance away from the beacon, and the X position is the offset from left to right of the beacon.
Another thing we did in the community is we toured a factory called Made. They specialize in making LEDs, as the board shows. While in their factory, they showed us that they have a 3-step process to making these LED boards. They take the boards with the customer's custom order and send it through the 3 machines. One applies paste where it's necessary. The second one puts the LEDs on the board, and then the third one will solder everything down. So then they came back to us and told us that after the boards are soldered, it's almost impossible and way too expensive to fix it. So they want a station after every machine, but it cost $100,000 for each of these cameras. So we showed them our vision processing system and how it can actually count all the LEDs on the board.
Lastly, we created a business plan to ensure that we track our team progress and to help us be known not only as builders of robots, but as contributors to society. This business plan includes our financial plan, team goals, and an analysis of our strengths and improvements as a team.
I see your 7th, 8th, and 9th graders, correct?
Yes.
So this team has been in existence for a number of years. So it's a team that's been in your school.
Yeah, we've been around for 4 years.
Been around for 4 years. When do you meet? When does your team meet?
We usually meet Wednesdays and Saturdays for about 2 or 3 hours.
Sometimes we meet Mondays.
Depending on how close it is to
Yeah.
the competition.
Lots of kids here have other sports and stuff.
And you meet at the school? Or
No,
We had
we're
a
meeting
bill
at one of
sign
our
outside
spots.
school. People from last year let us use. So during our build season, we invited another school team from our district. They didn't have a very good build site or field, and we invited them into our build site, let them practice on our field, and helped them out with their building during the season.
Personal or as a team?
We were also active on the forum to help with some of the gyro problems that were occurring.
If you do not win today, do you want to come back?
Yes.
Yes.
We plan to come back.
Someone who did not speak, tell us why.
Well, it's mostly a learning experience. You actually get all the hands-on, because most teams you're just there to watch as everyone else builds it. Everyone who's been doing this for years
But here, you actually get more hands-on. You know what's going on. You're learning a lot more than you would on a bigger team.
Anyone else? If you want to do this over again, is there one thing that you guys want to not do?
Because all the problems that we might have had, those are just learning experience. So we can take those, learn from them, and move on. And that'll help us out next time.
Okay, so I see some old people in the back row here. Sorry. How do you attract mentors? How do you interact with the engineering community? You talked a couple of things. Your mentors come from the school,
Well, usually our mentors are kids on the team's parents, and they help us out throughout the season on like things like the build process and sometimes on the engineering notebook.
How do you set up your engineering notebook? I mean,
You see, one of the mentors showed us how to put all this stuff, like pictures on it and everything, words on a PowerPoint, and then we printed it out and put it all together in a giant file.
I guess I didn't ask that correctly. Is there somebody in the team that their job is to kind of oversee the notebook?
That would be, well, my dad was mainly in charge of doing the notebook.
Everyone on the team.
The team did something.
Okay, so did everybody take like
Yeah, my dad was.
a day or something?
Yeah, we would each take time to go
He's
off.
not here right now.
Somebody yourself, a person just first.
Okay, so it was a community, a team wide.
Yeah, we all did the engineering notebook. We just had some mentors like overview.
Absolutely. Can I look? I'm mechanical.
I see lots of tech experts on here.